Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. And if you need global distributions, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, Alluxio, and Data Council. Go to dataengineeringpodcast.com/conferences to learn more about these and other events, and take advantage of our partner discounts to save money when you register today. Your host is Tobias Macy, and today I'm interviewing Kent Graziano about SnowflakeDB, the cloud-native data warehouse. So, Kent, can you start by introducing yourself?
Sure. Thanks for having me, Tobias. I am the chief technical evangelist for Snowflake. I've been with the company for just a little over 4 years now. Joined it when there was only about 100 people in the company. Career-wise, I have been in the data space for nearly 30 years. I've been doing data warehousing for over 25. I've co-authored books with Bill Inman and Dan Lindstedt, and I have done everything from being a independent consultant to being the director of a data warehousing team for a public school system, as well as government contractor, and worked in the healthcare space as well. So I've seen the, I'll say, ups and downs of the industry over the last couple of decades, and am still excited to be in.
And do you remember how you first got involved in the area of data management?
Yeah, actually I do. I was on a government contract in Denver, working at the Denver Federal Center with the Department of Interior, and got into a job initially as a programmer and had the manager come to me and say, hey, I just came back from this class at IBM on relational database design. Does that sound like anything that might be of interest to you? And then he proceeded to explain third normal form to me, and I was basically hooked at that point. And the project involved in a couple of months to me getting my hands on Oracle version 5.1a and installing it on a PC and building out the very first relational database system for that particular government agency, which was simply combining 3 mailing lists that were being managed in a COBOL system into a single database. That was, as they say, the beginning of the whole thing.
And so, as you mentioned, now you're the chief technical evangelist for Snowflake. So I'm wondering if you can just start by explaining a bit about what the SnowflakeDB platform is for anybody who isn't familiar with it.
Sure. So Snowflake is a cloud-based data platform. It started off as really what I used to call a data warehouse as a service. So it was built in the cloud for the cloud to allow people to load and analyze data at massive speeds, and taking advantage of the native architectures that are brought to us by the cloud.
And I know that there are a lot of architectural changes that come about as a result of the fact that it's designed specifically for cloud-native environments. I'm wondering if you can compare it a bit with some of the other available platforms for data warehousing and maybe highlight some of the differences in terms of the operational characteristics and usage characteristics from traditional data warehouses.
Sure. In the data warehousing world, we, over the last couple of decades, have evolved from basic relational database systems to our MPP, massively parallel processing systems, with either a shared nothing architecture or a shared disk architecture. And what the founders of Snowflake did is, because of the nature of the cloud and looking at the nature of the cloud versus a on-premise sort of system, they invented a completely new architecture called the MultiCluster shared data architecture, which separates the compute power from the storage so that we can independently and elastically scale the storage and the compute. In the previous architectures, basically, if you wanted more storage, you had to get a bigger box and it had more compute for the most part. If you wanted more compute, many times you were forced into buying, again, a bigger box that had more storage that you might not need. And you were also found that you were generally bound by the compute power of the box that you bought. Say it's 16 CPUs. And while 16 CPUs may have been great when you started your data warehouse and you had 20 users and one ETL process, if you had the great opportunity to build a wildly successful platform and you suddenly found yourself with hundreds or thousands of users, they're now bumping into each other and they're having to compete for that shared resource. And with the architecture that Snowflake has developed, you can actually create independent compute clusters for these different workloads, which allows us to really scale to a near infinite level for the number of users and number of processes that can be running, and at the same time make sure that they are not contending with each other for limited resources. Really allows people to be much more agile in the development of their ecosystem, as they can start very small and grow to very large without having to go out and purchase another system and do a migration. It's all dynamic and elastic on demand in the cloud.
And then there are a number of other competitors that are targeting the cloud environment, most notably things like BigQuery or Redshift, and recently Redshift Spectrum. I'm curious if you can give a bit of comparison to the characteristics of Snowflake as it relates to some of the other cloud-native implementations that people might be familiar with. And then also sort of on the more data lake side of things, systems such as Presto or some of the SQL on Hadoop or SQL on unstructured data solutions.
Sure. Yeah. Most of even some of the systems that are calling themselves cloud native, they are all based on the previous architectures that I talked about, whether it was shared nothing or shared disk architecture. And while they may be in the cloud, for the most part, they are slight evolutions of the original architectures. And so they don't offer this dynamic scalability under the control of the customer on demand. You have things like query engines that can scale quite large, but in general, the customer doesn't have a lot of control over that, which means they can throw a really large job at it and it can scream and just really do a great job. But they don't necessarily have the control over how much resource is being thrown at that, which means that in the end, they don't have a lot of control over how much that may cost them. And some of the other ones are really ports of the older architectures into the cloud. And so you're looking at things that are effectively VMs, and the architecture is still the same, where the compute and the storage is tightly coupled. If you need more storage, you got to buy more compute. If you need more compute, you got to buy more storage. Now, and to be fair, many of our competitors are obviously evolving, and they're adding things to their offerings here over time. We're starting to see that, but in the end, it ends up still being a fairly complicated engineering sort of feat for the folks who are managing the system. And that's one of the things that really differentiates us is the, I'll say, lack of management that you need to do. So what a traditional database administrator may have had to do with performance tuning and backup and recovery and things like that, we've taken care of all of that for you. Where in many of the other cloud-based data warehouse systems, the DBA still has that more traditional role and is having to manage things like distribution keys and vacuuming, as well as the sizing and forecasting of the utilization. And so that really does make a big difference. On the other side of the house, we start talking about data lakes and semi-structured data. One of the things that we did in Snowflake is we invented a new data type called variant that allows you to load semi-structured data into a column in a table and then access it natively with some minor extensions to SQL. So this saves people from having to parse it out and basically ETL the data into traditional tables and columns in comparison to things like Presto and Hive and some of the other tools that are out there that evolved out of the Hadoop ecosystem, where those really are SQL interfaces, if you will, on top of a file system. And so you do not have some of the traditional database features such as transaction consistency and ACID compliance. Those aren't necessarily there depending on which rev you're using. Again, those are all evolving, but what we've seen over the last 10 years is what started out as very sort of, I'll say, minimalist SQL, because we discovered everybody really understands SQL. They don't understand necessarily Java and MapReduce, that we had to build a SQL interface to make those Hadoop-style systems work. And today with the cloud, some of it's just blob storage, whether it's S3 on Amazon or Azure Blob Storage. We're still dealing with more or less a file system with a SQL interface built on top of it. And so this does require a lot more care and feeding, and it puts limitations on you as to what you can do from a traditional database perspective, which we've got all built into the Snowflake platform already.
And one of the things that you mentioned in there is this variant data type for being able to load semi-structured data directly into Snowflake. And I know that that's one of the attributes that has led to the current shift from ETL to ELT, where you're doing the transformations within the data warehouse itself rather than upfront, because I know that traditionally there was a lot of planning and rigor that had to go into loading the data into the data warehouse to make it accessible for other people. And so I'm wondering how the performance characteristics and flexibility of Snowflake and the availability of this variant data type and some of the schematic flexibility plays into the overall data modeling requirements for using Snowflake and some of the shift towards this ELT workflow.
It's been very interesting for me because I come from a traditional relational background with third normal form modeling as well as dimensional modeling and data vault modeling in the data warehouse world. So looking at Snowflake and the features that we have, even just looking at the semi-structured data, so whether it's JSON, Avro, Parquet, things like that, a lot of our customers have found they can load that into a column. So effectively you have a table now where there's might be a couple of metadata columns and a variant column, and then a single row in that table, that in that variant you'll have an entire JSON document that might have arrays and nested arrays and all sorts of really interesting structures within we'll call it the schema of the JSON document. And our customers are able to build views on that using our JSON SQL syntax and make it look like a dimensional model. And I found this incredibly fascinating and also incredibly powerful in that we are now able to do things like load weblogs into a database table, but make it accessible to, I'll say, your average business analyst in a dimensional format. So they can actually do analytics on this type of data now using Tableau, using Power BI, using tools that they're very familiar with, and they don't even know that it's JSON data under the covers. And so the combination of being able to load that type of data, the SQL extensions to access it, we've actually eliminated the T now in the ELT, extract, load, transform. The transform part is now a SQL view. And it's transforming the structure into something that a business analyst understands, but we're able to then load data much faster and really reduce the latency and the time to value for that data. And the performance optimizations that are built into Snowflake, combined with our ability to do these independent compute clusters, which we call virtual warehouses, allows us to get the performance out of that. There's literally no indexing. There's no manual partitioning. There's no distribution keys, and so the DBAs are not having to spend, I'll say nights and weekends trying to make this stuff perform. We're able to just build the views on it, expose it via Tableau, and the business analysts now have rapid access to all of this data. And additionally, we can allow them to join that semi-structured data now to structured data that might have been loaded, say, from a CRM system in a more traditional scheme. From a data modeling perspective, there's two factors here with Snowflake. One, in the scenarios we're talking about right now with the semi-structured data, is we're doing almost virtual modeling, right? The modeling approaches, whether it's 3NF, Data Vault, or dimensional, can all be done with views. So it's more about what is the right structure to represent the data in for the business use case. And that also means that you can have one set of data and have multiple representations of it serving different use cases. And this really gets us down to that concept of the single source of truth that we've been trying to reach in the data warehousing world for several decades. The other aspect of modeling with Snowflake is the system was designed to be what we call schema agnostic, where many of the traditional on-premises database systems really preferred a specific modeling technique, be it third normal form or dimensional for the most part, and required specific tuning to make those things work. Snowflake was designed to be performant against any modeling technique because we wanted to ensure that wherever our customers were coming from in their legacy on-prem world, they wouldn't necessarily have to change their approach to modeling in order to get effective use out of Snowflake. And so that was actually designed from the ground up. One of the things that I didn't say earlier is our founders wrote Snowflake completely from the ground up. It's a brand new relational database. So not only did they invent a new architecture to take advantage of the elasticity and the dynamic nature of the cloud and to eliminate the concurrency and performance issues that people have had with the traditional systems, they were able to do this only by starting from ground zero and not forking some previous code base. So it is all new code resulting in this really dynamic data platform that can be used for, as we were talking about, data lake types of applications, as well as traditional analytics applications, and be ANSI SQL compliant as well at the same time.
And there seem to be sort of two driving factors for when somebody might decide between using a data lake versus a data warehouse, one of which being the flexibility in terms of the types of data that you can load in and the availability for how to analyze it, which is in large part addressed by the flexibility in the schematic modeling that Snowflake offers, and the other one being cost. And so I'm curious what that looks like in terms of a breakdown for the overall spend that somebody would be dealing with on particularly the storage side, but also to some extent the compute of storing everything in an S3 data lake or possibly even HDFS versus what you'd be storing for the same volume of data in Snowflake, and then the amount of time and compute energy required to be able to derive value from it, or the amount of data copying necessary, particularly in the data lake scenario of being able to then transform it into different forms for being able to run various analyses on it.
Yeah, that's a great question. One of the things with Snowflake is that we are MPP style, right? So massively parallel processing using the MPP compute nodes in the cloud. But on the storage side, we actually have implemented an advanced columnar compression algorithm as well. So from a pure storage cost perspective, our customers pay basically the same price for storage as you would on the underlying cloud vendor. So in the case of AWS, we're talking about S3 storage, and because under the covers, that's what we're using. But the difference is we are giving them 3 to 5x compression on that data. So from a pure data lake storage perspective, you can store that data in Snowflake and in all likelihood be paying way less because of the compression that we have. Our terabyte per terabyte storage cost is effectively the same as blob storage, except that in our case, we're able to compress it. So you're going to get from 3 to 5 terabytes compressed into 1 terabyte of storage. So that's a huge cost savings for our customers. And that's why it's become feasible for them to consider putting their data lake in Snowflake as well as their data warehouse and doing all the analytics. Now, your secondary question there is, okay, if we put the data lake and we put all that data in Snowflake, how much is it costing us? What does that look like to then transform that into analytic style schemas? And as I mentioned before, in many cases, if we're talking simply about the semi-structured data and even structured data, a lot of our customers are just using views. And so there's the cost there ends up being in the compute to execute the query. Where in the past, you may have had costs for doing actual ETL processing, where we do certainly have customers that are doing transformations within Snowflake as well, where it's necessary to apply some advanced business rules, some data cleansing rules, things like that. So you do have that as well. But that cost in the case of of transformations, whether you're talking ETL or ELT, is something that they were paying one way or another before already. The advantage again with Snowflake is our customers are finding that our system runs way faster than their prior systems. I know of one customer that had a report that ran for 20 hours on their data warehouse appliance, and by simply moving that data in the schema over to Snowflake, they ran in 45 minutes. And so they experienced a massive cost reduction in looking at the cost of compute on Snowflake in comparison to what that massive data warehouse appliance costs them. And it is a different cost model for sure. I mean, it is a pay-as-you-go model. In the case of Snowflake, we charge per second per node. So when you create these virtual clusters, we're talking about how many nodes are there? Is it a single node? Is it 2 nodes? Is it 4 nodes? Is it 8 nodes? But we charge on a per second per node basis and generally get linear scalability. So if somebody wants to run something faster, they use a larger virtual warehouse and it'll run in half the time. But because of the pricing model, it costs them exactly the same amount of money. It's just that it ran faster. And so then we start talking about the value of the time and what else they can do when they have access to that data so much faster.
And another thing that you mentioned a couple of times is the fact that because of the ability to create these views on the underlying data structures, you, in many cases, can just have it living in one place and you don't have to worry about copying it. And so I'm curious how that plays into the requirement for a master data management approach for ensuring that there are canonical schemas or canonical IDs for users or sales products or things like that. And if that is still a necessary aspect of data modeling and data management in this Snowflake world.
It is for certain use cases, and it really is about what the business requirements are. If you're talking about a lot of raw JSON weblogs and they need to do data science on it and try to derive some insights from that data, then they're pretty much good to go with what we've been describing. If you are looking at building, I'll say, an enterprise data warehouse in a highly regulated industry that needs to be compliant with GDPR and CCPA and some of the other regulations that are out there, then we do have our enterprise customers, the really big organizations are still building canonical schemas and doing more of the traditional transformations and master data management type approaches. I think the beauty of Snowflake is that it allows you to do either or. You're not locked in. You have the flexibility based on the requirements of your business and your approach and what you're trying to achieve. So we do have people doing both for sure that are porting over things that are what I call the highly integrated enterprise data warehouse where it does require an integration layer using something like a data vault modeling methodology, where you will have stage tables and you will have a core granular data warehouse that is aligning the business keys and making sure that when the reporting comes out that we have a common agreed upon representation for a product or a customer. So all of that still does happen, and again, it just varies from customer to customer as to what their business requirements are.
And so you mentioned that the high level view of how Snowflake is implemented is that there's the underlying data storage in the cloud object store, and then you run the compute on top of that in a sort of virtualized way and in a way that gives you some segmentation in terms of who can access what. But I'm wondering if you can dig a bit more into how the Snowflake platform is architected and some of the ways that it has evolved over the years.
Sure. So again, the storage layer, as we were saying, under the covers, whether it's on AWS or Google, is we're using the blob storage native to that cloud, and we are writing our own proprietary file structures into that storage. As a Snowflake customer and user, you don't see it as S3 storage. You don't see any storage, really. I mean, you look at a chart and see how much storage you're using, how many terabytes of data you're storing, but you can't access or see these files. It's all something we've built that's patented file format and structure and metadata around that, and that's the storage under the covers. And then the compute layer is then using the compute nodes. So in the case of Amazon, we're talking about EC2 nodes under the covers, complete with their SSD. And that becomes our dynamic memory, if you will, along with the number of threads on the compute cluster that someone has allocated. That holding that all together is what we call the global services layer. And that's really the brains of Snowflake. And that is where the metadata engine is, that's tracking where all the files are, tracking who the users and the roles, all the role-based access control and the security is all tracked in there as to who has access to what compute resources, who has privileges to create new compute resources, who has privileges to create new tables and load data, all of the standard things that you would need in a database from a role-based access control perspective. But it also, the global services layer manages the transaction consistency, the ACID compliance, and manages all the security from an encryption perspective. Our underlying data is always encrypted. It's 256-bit encryption at motion and at rest. So as you are uploading data into Snowflake, that data is encrypted on the client side before it comes over the wire into the Snowflake ecosystem, and then it is encrypted at rest. And we use a fairly robust hierarchical encryption scheme to make sure this stuff is all secured, complete with rotating keys, because one of the biggest concerns in the cloud was always, is our data secure? And I worked in many traditional database environments over my career where the data was never encrypted, and everyone was counting on the firewall to keep the data secure, when in fact people were able to get through those firewalls and read the underlying files and actually glean data out of those underlying files. Snowflake was built to make sure that could never happen. And because of that, we are HIPAA compliant, we're PCI compliant, we have SOC 2 Type 2 and SOC 2 Type 1 certifications, along with a number of other security certifications to ensure that our customers' data is always secure, that there's no way anyone can get to it. And so that's all combined there. So it's really the three layers: the global services layer, which is the brains, your compute layer, which is dynamic, where you can create as many of these independent compute clusters as you want. And then at the bottom there is the common storage layer, allowing us to have one set of data. And again, not having to copy it between silos and data marts, but to have one set of data accessed by all these different compute nodes.
And my understanding from previous conversations that I've had, one of which was actually on this podcast, I understand that the actual metadata layer for Snowflake is implemented on top of FoundationDB so that you actually have one location for being able to identify where all these files are located in the broader S3 storage rather than having to actually query the S3 API and deal with those latencies for being able to seek through information as you're trying to run a query. And I'm wondering if you can talk to either that or any of the other performance optimizations that are built into the system to ensure that it is operating at the sort of maximum performance that you're looking for, and to be able to provide that reduced time to value for your customers.
Yeah, and that's absolutely correct. What you were told before, it is under the covers. Our metadata engine is based on FDB, and we retain, I'll say, the addresses of all of the data in there, so that when someone is querying the data, it goes in there and looks for the data, but depending on the nature of the query, the names of the tables, all of that's there, and has pointers directly to our underlying file system to find that data as quickly as possible. And in fact, we keep the along with all the pointers there. Part of it is keeping the range of the data to know that from A to Z of this particular column, you can find that in this set of files under the covers. So we have that sort of direct pointer there. So when people are writing queries, based on the predicates and the join conditions, we have a lot of metadata information to allow us to go directly to the files where that data is really stored. I mean, again, to a customer, it's a table, right? But under the covers, those tables are made up with a lot of very small files, which we call micro partitions. And one of our primary methods of performance is called partition pruning, and it's based on the ability of the system to look at the query, go to the metadata, and then go directly to the set of files that contain the data that this query is asking for. So we're not having to do what would have been called, I'll say, in the old database world, a full table scan. Obviously, if somebody needs to do that and they want to do an aggregation on a trillion row table, well, it's going to do a full table scan. But if you're doing something more of a dimensional analysis, and we want to see all the sales for product X, for region Y, for sales rep Kent, we're going to be able to hone in on that data set very quickly and only return that set, even if we're talking about multi-terabyte tables and even into the petabyte range.
And then in terms of the overall system architecture and the implementation details, I'm wondering if there are any sort of edge cases or limitations that you're dealing with, or any of the specific challenges for being able to design and implement this across multiple different cloud vendors.
Oh yeah, that's interesting. That gets into the fact that we are cloud agnostic, and there hasn't, in the experience that I've had with Snowflake so far, there doesn't seem to be anything that we can't do on one that we can do on one that we can't do on another. And that was, again, the goal of the founders, is they developed Snowflake with this global services wrapper around it. And we're really writing to the APIs of the underlying cloud vendors, so that we can ensure that whether you choose AWS deployment or Azure deployment or a Google deployment, your Snowflake experience is exactly the same in all three. And one of the things that is coming, that we just released earlier this year, is the ability to not only do cross-region replication within a cloud provider, but we now have the ability to do cross-cloud replication. So you could actually be running Snowflake on AWS and replicate it to Snowflake on Azure as a mechanism. In some cases, some of our customers want to do that for disaster recovery and business continuity. In other cases, it may be for latency reasons, and in some cases, it may be for business reasons, where there's certain data sets that, for whatever reason, they only want it in the Azure space, and other data sets they may want or need to have in an AWS space for various business reasons. So we've done quite well because the system was designed from the get-go not to be single cloud. It was designed to be cloud agnostic, and so we have not had these issues where, hey, this feature works great in AWS, but it doesn't work in Azure.
And then for people who are interested in getting started with using Snowflake and loading their data into it, what are some of the options that they have for being able to populate the data warehouse that they set up with their data, and some of the overall workflow of then allocating and scaling the compute capacity for being able to run analyses, and maybe some of the options for cost optimization to ensure that they don't leave those clusters running when they're not actually being used?
Yeah, well, I'll start with that one first because that's the easiest one. We have, when you create a virtual warehouse on Snowflake, we have an auto suspend and an auto resume feature because it is a pay as you go. And what we've discovered over the years is many workloads do not need to be running 24/7, 365. In fact, in business intelligence and dashboarding, all that, in many cases, it's, people come in, fire a query, they get the results back, and they're good for the day, really. And so we have this auto suspend feature where the customer controls that with a parameter to say, if the compute is not being used for X number of seconds, minutes, hours, up to them, it automatically shuts down. And then the auto resume feature, the next query that comes in to hit that cluster, it automatically turns it back on. And so that's a great cost control, and people are finding that they're saving certainly a lot of money that way. In that we bill at a per second basis. So something runs for 5 seconds, you pay for 5 seconds. Runs for 5 minutes, you pay for 5 minutes. It runs for an hour, you pay for an hour. One of the other scaling features is we do have the ability to dynamically resize. So say you are running a use case that normally runs for an hour, and you're running it on a small virtual warehouse, which is 2 nodes, and you need to get it done in 15 minutes. Well, then you alter warehouse resize to a large, and now it's running on 16 nodes, and it's going to run in 15 minutes instead of an hour. But it costs the same because it's per second per node. And so that's a really cool feature that we have that people do use on a fairly regular basis. On the storage side, and how do we get our data into Snowflake? And that's obviously a very common question. How do we get data into the cloud if all of our data is in data centers? And we have a very open ecosystem of connectors, where we started off with we have a native Python connector, an ODBC connector, a JDBC connector. We even have an optimized Spark connector. People were writing their ETL using Spark, which many organizations have been doing. It's allowed all the traditional ETL vendors and ELT vendors have connectors. And so if you're currently using SSIS or Talent or Informatica, you can repoint that to Snowflake and continue to use the same flow that you're using today. Then, of course, there's new ones like Fivetran and Matillion that are tools that are more born in the cloud themselves. You have an option to do those. In fact, we even have a partner connect feature. There's a dashboard when you log into Snowflake where you can sign up for free trials for some of these tools. And I've heard from customers that are doing a POC with us that they got access to their new Snowflake account. They went in, and within 30 minutes they were up and running, provisioned with one of our partner tools, and loading data from their old database into Snowflake. And so there's any number of options. You can use Kafka. If you happen to be running in a Kafka environment, we just released our Kafka connector using Confluent, and so people are able to run data from Kafka straight into Snowflake. We have I'll say the traditional methods if you could upload your data into a blob storage bucket and then copy it into a table in Snowflake. We have our own ingestion engine called Snowpipe that allows us to take data that is dumped into a blob storage bucket and automatically pick that data up and load it into tables in Snowflake. And there's even a button on our web UI where you can click a button to load data in and specify the table you want to load the data in, specify the file you want to pull it from, and you could be pulling it off your laptop and more or less, basically manually load it using our web UI. So there's a very large variety of options for customers to choose from in how they're going to load their data into Snowflake.
And another one of the interesting features that's enabled by your architecture is the data sharing capabilities for being able to say that this data set is available to somebody else who's running a virtual data warehouse. So that opens up the possibility of things like data brokerages or allowing a certain subset of data to be shared between different business units or organizations. And I'm wondering what you have seen as some of the most interesting or unexpected uses of that capability.
Oh yeah, that's pretty much everybody's favorite feature these days is data sharing. That any organization now can become a data provider and effectively build what I refer to from my architectural framework as a curated data mart and grant access to that data mart to any other Snowflake account holder, and it appears to them as a read-only database. And that has evolved now into us having, we now have the Snowflake Data Exchange, which is available in, it's a public preview now on one of our regions where customers have signed up and are actually making data available, like weather data. AccuWeather has a tile on there that you can sign up to get weather data and get access to that to augment your analytics in your data warehouse on Snowflake. And then just this week at AWS reInvent, we announced the private data exchange that we're now actually going to be allowing customers to internally within their organization, rather than a public data exchange, define these data sets into a much, I'll say, user-friendly interface and specify other organizations within their company or potentially specific business partners that they want to allow access to this data in a very resilient manner and a very secure manner. One of the most interesting usages of this was very early on with one of our customers that had a partnership with another Snowflake customer, and they provided analytics on YouTube videos. And so they were collecting all of that sort of data and shared it over to the other Snowflake customer, who then did augmented analytics on it with more consumer-related data that they had. And so they were effectively joining that data to the YouTube analytics and providing a different level of analytics. And then in turn, sharing that data back to the original data provider. So effectively, the raw data is coming from one organization and sharing it to a partner organization who then augmented it with their own data to get a more sophisticated data set and then sharing it back to the original provider. And then the really interesting thing about it was when the original consumer turned around and bought the provider, and it actually became one company. And the amount of money that they saved by not having to do manual transfers of this data was incredible. And their return on investment was quite amazing to see, because it eliminated even before the acquisition, they were dropping files onto a secure FTP, and then the other organization has to have an ETL process to ingest it into their data warehouse. They were doing their analytics on it and augmenting it, and then having to spit that data back out to flat files to a secure FTP site, and then the whole process goes over again. And that was quite fascinating to see that particular use case, because I call it bidirectional data sharing, and it's it's really interesting to see what people can do with these features. And in many cases, it may be use cases that our founders might not have even thought of when they first started. But it was all a result of the separation of compute from storage. Because the storage is centralized, separate from the compute, that's what allows us to do data sharing and to create this logical share container on the storage layer and have it accessible by compute that's in a completely different Snowflake account.
And what are some of the other features that are what are some of the other features or use cases for Snowflake that are not as well known or as well publicized as this data sharing capability, which you think users should know about and would be able to benefit from?
Well, there's a couple that I think the DBAs really love. There's a feature called Undrop that allows you to instantly recover anything from a table to a schema to an entire database. So the classic Monday morning oops, somebody comes in, thinks they're logged into development, they're logged into production, and they drop a set of tables because they're about to do the next iteration and then realize, wait a minute, I was in production. They simply issue a command, undrop table, undrop schema, whatever it was, and it's instantaneously back. And that's one of the I'll say it's a side effect of our feature called time travel, which allows you to query your data as it was at a previous point in time. And by default, all of our customers get 24 hours of time travel. So if you're running an ETL process in the morning and later in the afternoon, you discover that, hey, there's something wrong with that process, they can very easily roll it back by they can take a look at what it looked like before the process ran, and you can go all the way up to 90 days with it. So it's there's literally no configuration other than setting the parameter. But because of that feature, that allows people to do things like undrop. If you've got a 90-day time travel window, you could actually recover something that you dropped 89 days ago instantaneously. And that's a really cool feature. One of the other ones, which I don't think people know a lot about, is we actually do result set caching. So for when you run a query and it produces a result set, that data set is actually cached for 24 hours. And you can go into the history tab in the Snowflake UI and review the query that you ran 23 and a half hours ago and see the data set and actually take a look at that data set without having to re-execute the query. And so there's no cost involved in that particular one. And so from a development perspective, I found that very, very useful. The classic, 5 o'clock, I'm working my way through building out a particular SQL query, go home, come back in the next morning and trying to remember where was I? Well, instead of having to rerun the last query that I ran before I went home last night, I simply go back and look at the results cache, and I can see the data set, I can see the query, and then I can continue on from there without having to have the cost of re-executing the query the next morning.
And so with all of the different capabilities and flexibility and benefits that Snowflake can provide, it's easy to assume that it's the right choice for every situation. But I'm wondering what you have seen as being some of the cases when Snowflake is the wrong choice.
Well, for one of the things that people used to ask me when I first started, because we always said, we were a data warehouse, is like, well, no, it sounds like it's a database. And yes, Snowflake is indeed a database. And now we say Snowflake is really a fairly robust data platform. The one thing you absolutely would not want to do with Snowflake really is an OLTP application where you're doing singleton inserts and queries, because it is an MPP system. There's 8 threads on our smallest virtual warehouse, and you're certainly going to be grossly underutilizing it if you're doing singleton inserts. So any sort of really single row type of application is probably not necessarily the best. Micro batches, continuous feeds, things like that are okay, though we are working as part of one of our enhancements, working on the improving our ability for low latency type requests. but you really wouldn't want to build like a order entry system on Snowflake, even though you could with you could use our Node.js connector and build a very fancy web UI order entry system from scratch, but that would just not be the right thing to do with Snowflake.
And what are some of the plans for the future of SnowflakeDB, either from the technical or business side?
Well, on the business from a business side, the whole business continuity story and global Snowflake is very big, where we are moving forward with our cross-cloud replication. And one of the things on the roadmap will be an automatic sort of failover that if your primary Snowflake account fails for some reason, the service goes down, the telco, the lines go out for a particular availability zone, that it will automatically fail over and automatically fail over the applications pointing to Snowflake. So that is on the roadmap. It's a thing we call organizations. They're going to allow you to have basically one organization with multiple Snowflake accounts under it that are all very well connected. Another is our geospatial support. So we're going to be rolling out some support for geospatial data types, including GeoJSON. And you can imagine there's certain industries that's going to be a really big hit in. So I know that's coming down the pike. And then with all the regulations and concerns over privacy, we are going to be adding column level access controls, including dynamic data masking. And that's going to be, that's a feature that's been requested, particularly in the healthcare and financial industry space, to be able to do it not just at a row level, but to do it at a column level, and to incorporate data masking functions into Snowflake directly.
And that's one thing that we didn't really touch on yet is the specific SQL dialect that Snowflake is using. I'm wondering how closely it's sticking to the ANSI standard, and what are some of the interesting extensions or built-in functions that it provides?
Yeah. So it is an ANSI standard SQL. The extensions, I think I mentioned a little bit already, was the extensions we've had for accessing keys within JSON and semi-structured data, as well as XML. And so there's some extensions there. We have a very extensive SQL function library, which people can check out in our documentation. You can just go to docs.snowflake.com and look up the SQL library. And so we have a full set of windowing functions and statistical standard SQL statistical functions, things of that nature that are already in there. We also have the ability for customers to write user-defined functions, as well as recently we've added support for stored procedures. Kind of back to our ELT conversation a little earlier, we recently introduced a feature of streams and tasks that will take advantage of stored procedures to do some change data capture within the Snowflake engine. So as new data is loaded, you can create a stream object on top of the table to look at things that have changed, and then launch a task to move the data further downstream. So we're really working on expanding what I'll call true ELT capabilities within the Snowflake engine itself. But all standard SQL, standard SQL functions to do the transformations and calculations that people have typically needed to do, and even to the point of doing some data science type calculations. One of our customers built a data science application completely using Snowflake SQL. That the data scientist said everything he needed was in the library to do the statistical analysis that he was trying to achieve.
Are there any other aspects of the Snowflake platform, or the ways that it's being used, or the use cases that it enables that we didn't discuss yet that you'd like to cover before we close out the show?
Wow. It's being used in pretty much every vertical. So we've got folks that are using Snowflake now for security analytics, and we have an open source system that we've put out called Snow Alert, And that's a really interesting use case where people are even using Snowflake to replace some of the functionality that they were previously using things like Splunk for. Marketing analytics, we have quite a few customers that are doing marketing analytics using Snowflake, and then certainly healthcare, as I've already mentioned. We have well over 100 healthcare related companies doing healthcare analytics. Some of the companies are actually building analytic applications on top of Snowflake. So they're providing an analytics service to their customers that's powered by Snowflake under the covers. And we're starting to see, I'll say, more and more of that sort of thing, kind of in many cases in combination with data sharing. So lots of interesting applications, and this sort of hybrid, being able to do your data lake and your data warehouse all in one platform is certainly a growing use case. And with the addition of streams and tasks and our ELT capabilities, I expect to see that growing even more over the next couple of years.
And so for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
There's a lot of tooling out there. I mean, the biggest question I keep getting on is things like data catalogs and for large enterprises. And there is some tooling out there for that. We have a number of partner companies that specialize in data catalogs. And I see more of a knowledge and process gap, honestly, than a tooling gap. Is just people understanding the need for data governance and some of the best practices around data management that are necessary to make effective use of all of these really large data sets that people are now starting to deal with. And it ends up being more of a process than a technology question right now. The only thing I'll say on the Snowflake side that we don't handle at this point is things like images and sound, MP3s, closer to what people would think of now truly as unstructured data, though in reality they all have some amount of structure in it. So that's a little bit of a gap that I think we have right now that I know we're looking at, and we have customers asking us about that, about how we can integrate some of the use cases around that as well.
Well, thank you very much for taking the time today to join me and share your expertise and experience of working with Snowflake. It's definitely an interesting platform and one that has been gaining a huge amount of popularity and mind share. So it's great to see the directions that it's going and some of the capabilities that it provides. So thank you for all of your time, and I hope you enjoy the rest of your day.
Thank you very much.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.